Now that we have our surface grid set up, we can begin to use this grid to populate our model with adaptive components. I'm going to begin with the structure. I'm going to grab the component known as the slice list component. This will allow me to slice up the grid into rows. After connecting the XYZs into the list input, I now need to establish a way to slice up these XYZs into rows. I'm first going to grab an addition component. I'm going to connect in the number 1 into the Y input of addition. The V division count of 2 actually results in 3 points. I want to connect in the number 2 into the addition component and add it by 1 so I have the correct number of points to slice up my row. Now that my list is being divided up, I am now ready for the adaptive component by points. I'm going to connect my sliced list of points into the XYZ input. Minimizing Dynamo, I'm now going to show you the adaptive beam that I'm going to use with this system. This beam is being placed by 3 points in space. I'm going to load this into my project file. Inside of Dynamo, I now need to find the Select Family Type component. This will allow me to specify the name of the family that I'm going to place with my system. After you find the Select Family Type component, in the drop-down, find the name of the beam that we are going to place. You can now connect this into the family input. For clarity, I can now hide the selected surface element from the view. This will allow me to see how my adaptive components are being instantiated. In the lower left-hand corner, hit the Run command. Dynamo will now place all of the adaptive components along the rows that have been specified using the UV grids. We are now going to achieve the paneling grid using a user-defined custom node. A user-defined custom node needs to be installed in a special way. Before we install it, we need to make sure that we are saving our Dynamo definition. After you have saved your definition, close Dynamo. A custom node called Grid to Quads has been supplied with this tutorial. To install it, you must first find your Dynamo folder. Your Dynamo installation folder is typically located on your C drive. Find the Autodesk folder, followed by the Dynamo folder. Go into the Core folder, and then find the folder called Definitions. Here you can place your custom node file. After you have loaded the custom component, you can now return to Vasari. Once in Vasari, you can restart Dynamo and find the definition you saved before. Once inside of the definition, you can search for a component called Grid to Quads. This will organize an XYZ list into quad cells for use by an adaptive component. We first need to establish the row count. I'm going to copy and paste the number in addition from below. I'm now going to connect my uCount slider into the first input of addition. I'm now going to plug addition into the row count of the grid to quads, followed by the evaluate UV in for the grid input. I now have an order list of quad points. I can now use a new adaptive component by points to place adaptive components in a paneling configuration. Inside of Vasari, I'm going to open up my paneling adaptive component. Here you can see the adaptive component uses 4 points for its placement. I'm going to load this into my project. Inside of Dynamo, I now need to find the Select Family Type component. Within the drop-down, find the panel component. You can now connect the select family type into the family symbol input of the adaptive components by points. When you run the definition, Dynamo will iterate through each quad cell of the point grid and place a panel along the surface. Inside of Vasari, we can now select one of the adaptive components and edit some of its parameters. In this case, I'm going to edit one of the type parameters of the component. I'm going to increase the thickness of the outer frame. Even though I've adjusted the type parameter, Dynamo will allow me to continue linking back to these components and update their positions. Another interesting workflow is to go back and alter the original surface. I'm going to find the original conceptual surface I created before. In this case, I'm going to alter the position of one of the vertices. After I've performed a few modifications to the surface, I'm going to reload the surface back into the project environment. Vasari will ask me if I want to overwrite the existing version. I'm going to choose yes. Nothing has yet happened to my paneling system. If I load Dynamo back up, I can choose to run the definition again. Dynamo will recognize the surface has changed positions and will update the entire system. Scenarios like this provide many interesting opportunities for mixing and matching Vasari modeling techniques with Dynamo automation. By leveraging Dynamo in the overall BIM workflow, the designer has opportunities to customize their process for new levels of efficiency and innovation.